In this video, you'll be introduced to the Pythagorean theorem and how it can help you to determine if a triangle is in fact a right triangle. If you're following along in your notes, please write down these topics in red with the appropriate page numbers. All right, let's get started. By the end of this lesson, you should be able to say that you can classify a given triangle as a right triangle by determining if its three sides form a Pythagorean triple. So let's get started. Who is Pythagoras and what is his theorem all about? So a theorem is like a main idea, right? So Pythagoras was a Greek philosopher who was born way long time ago in 569 BC. He's often referred to as the first pure mathematician, although there were many at the time. Pythagoras studied many relationships with numbers, but he's most famous for his study of right triangles. So Pythagoras investigated the relationship of the lengths of the sides of right triangles, and he found that there was something special about the relationship of these numbers. So the first thing I want you to work on today is your vocabulary, and that is to identify that two parts of the triangle have the same name. They're called the legs, and they're what make the 90-degree angle, right? So if you were to identify a leg, that side of the triangle would have to be touching that 90-degree angle. The hypotenuse is the diagonal side that is always opposite of the hypotenuse. So those are some new words for you, right? A hypotenuse is pretty hard to say. So I sometimes like to show this picture of a hippopotamus, right? Now, that's not how you say it. You don't call it a hippopotamus, but sometimes seeing this mental image kind of helps you sort of remember what it sounds like. So again, it's called the hypotenuse, and it is across or opposite of the 90-degree angle. And the legs are what touch the 90-degree box, right? That right there, that's that 90-degree box that you see when they're telling you that it is in fact a 90-degree angle. All right, a triangle can be rotated in many different ways, but it will always have two sides that are legs and one side that is a hypotenuse. And the good news is that the legs are interchangeable, right? It doesn't matter which one I call leg 1 and which one I call leg 2. It doesn't matter because they're both legs. But notice as the triangle rotates or reflects, right? This triangle is a reflection of that triangle, that the hypotenuse is always across from the 90-degree angle. And if you can find that 90-degree angle, you can find the hypotenuse. So that's a main idea for you today. So let's take a look at this triangle. It has three sides that are labeled with numbers. Two of those numbers are legs, and one of them is a hypotenuse. Can you identify the hypotenuse first? Remember, the hypotenuse is opposite of the 90-degree angle. So if you always draw that little arrow mark, you'll never get the hypotenuse wrong. So if you can identify the hypotenuse first, you will always be right, because the order of the legs don't matter. So if the hypotenuse is 5, then that means that the 3 and the 4 must be the legs. That is an acceptable answer. So is this. So you really only need to identify the hypotenuse. And if you don't have a drawing, then all you need to remember is that the hypotenuse is always the longest side. So if all I give you are numbers, find the largest number first. That's the hypotenuse. And then you'll definitely get the legs right. Let's take a look at another example. I've rotated the triangle a bit just to see if it confuses you. So two of those numbers are legs, and one is the hypotenuse. Do you remember how to find it? Well, there's two ways. If you have a drawing, go to the right angle and go across. The second is to look for the biggest number. The hypotenuse in this diagram is 13. That means that the legs are 5 and 12, or 12 and 5. It doesn't matter. The legs always touch the 90-degree angle, so that's another way you can double check your math. So the hypotenuse is always the largest side. It's always across from the 90-degree box, and the legs always touch the 90-degree angle. How about this? What if I didn't give you a picture? Do you remember what the rule is? How do you know which one is the hypotenuse? That's right. It's the longest side. So the hypotenuse is 23. And it doesn't matter how I write the legs. One is 6 and one is 14. I think you're catching on. What about this one? What if I didn't use numbers this time? So if I don't use numbers, then you can't find the longest side. So you got to use the other trick, which is that the hypotenuse is across from the 90-degree angle. So in this example, the hypotenuse would be the letter C. And the legs are A and B. Again, in any order. All right, I think you're ready to try this skill on your own. The task here is to identify whether the side marked with the letter X is a leg or a hypotenuse. Pause the video now. All right, let's check your work. So number 1 is a hypotenuse because it's across from the 90-degree angle. Number 2 is not across, so therefore it's a leg. Number 3 is not across from the 90-degree angle, therefore it's also a leg. Okay, now that we've got the vocabulary out of the way, let's get into this formula. So the Pythagorean theorem is a formula that will help you to determine if a triangle is in fact a right triangle. Now, I know what you see on the screen here looks like a perfect right triangle, but without that little square in the corner, you technically can't be sure. It could be 89.999999999 degrees, which would fool the naked eye, but it isn't actually a right triangle. So we're going to talk about Pythagoras' big idea now. Pythagoras noticed that the length of the hypotenuse, right, the length of the hypotenuse, when you square it, when you times it by itself, was always equal to the square of both of these legs added together. So his theorem said, if you take the first leg and you square it, and you add it to the second leg when you square it, it's always equal to the hypotenuse squared. So instead of using those big long English words, we can shorten it up with this formula here. So the legs are sides A and B, and the hypotenuse is C. And you can write it all different ways, but these are all the same formula. These are all saying the same thing. Leg squared plus leg squared equals hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. Hypotenuse squared equals leg squared plus leg squared. Right? So you don't have to use any particular order here, right? You can use whichever one you like, but you have to recognize that they are the same thing, right? We've just used the commutative property here to change the order of the legs, but the formula is still the same. So his big idea was that if you square the two legs and add them together, they always equal the hypotenuse squared. So let's take a look at what that looks like visually here. Right, I'm going to show you a quick video. hopefully in that video you were able to see that these 9 squares plus these 16 squares always fit inside that 25 square box. It works every single time. It's pretty neat. All right, so let's work with this formula a little bit. All you need to do is to fill in the values for these 3 variables. Remember, do this one first. If you get the hypotenuse right, you can't get the legs wrong. So here's an example of what doesn't work, right? If a squared is equal plus b squared is equal to c squared, then that means it forms a right triangle. This does not. It's not even a closed polygon. This also does not. And this side here, this hypotenuse, is too long. So what we're going to do is see if this happens, right? If it doesn't happen, then this is true. But if the numbers aren't, it's because we have one of these 2 situations. All right, here's our first example. I don't have a right angle box because that's what I'm asking you. I'm asking you, is that a right triangle? I know it looks it, but is it really? So let's identify the parts. I've got 3 numbers, and the longest or the largest number is always the hypotenuse. So that means 5 is the hypotenuse. So I'm going to put that in the C position. So I take my 5 and I write it here instead of a C. Don't forget, that says C squared. Now what I'm going to do is take away the letter A and take away the letter B and replace it with these 2 values in any order. It doesn't matter who goes first. I guess I'll just go from least to greatest. So I'll put the 3, then I'll put the 4. Now we're going to prove that this is a right triangle. 3 squared is 9, 4 squared is 16, and 5 squared is 25. And when I add 9 and 16 together, I get a true statement. So this 3, 4, 5 triangle is a right triangle. So I would say yes, this is a right triangle. Let's take a look at another one. Again, I have a triangle here that looks like a right triangle, but is it really? So the numbers are 12, 13, and 14. Please fill in your hypotenuse first. For us, it's a 14. Then put your legs in any order. Get your calculator out and square these numbers, unless you have them memorized. 12 squared is 144, 13 squared is 169, and 14 squared is 196. When I add 144 plus 169, I actually get 313, and that's not equal to 196, so no, it's not a right triangle. When you are a right triangle, we call your set of numbers a Pythagorean triple. That means these 3 numbers make a perfect 90-degree triangle. And if you don't make a perfect 90-degree triangle, you're not a Pythagorean triple. Let's take a look at another example here. I have 6, 8, and 10. Don't forget, the formula is leg squared plus leg squared equals hypotenuse squared, also known as a squared plus b squared equals c squared. Put your hypotenuse in first, then put your legs in any order. Use your calculator to square, add the 2 together, and that's how you'll find your answer. Is it a yes or is it a no? This one's a yes. All right, I think you've got the hang of it. Try these 4 questions on your own. Determine if the following triangles are right triangles by using the Pythagorean theorem. I'm going to ask you to share your work on your worksheet afterwards. Pause the video now. All right, let's take a look and see how you did. 3 yeses, 1 no. All right, we're going to stop this video here, and in the next video, we'll learn how to use the Pythagorean theorem to find the missing sides of a triangle.